So hi everybody, my name is Pat McCarthy, and today we're going to talk about meter stuff. Um, Industry standard seems brief resume is the way to start. I like to joke that straight out of high school, I became a 0612 field wireman in the United States Marine Corps, and I had the designation of, or the good fortune of going through the U.S. military's shortest school, 3 weeks and a three-letter acronym that roughly translates to figure it out, and away you go. I kind of stayed in wires and construction stuff. 2008 happened, picked up a few more war stories, and then 2011, a job on Craigslist found me and has not let me leave since. That brought me into the world of CAISO metering. I have to make an honorable shout out because when I apprenticed in 2011, my greatest mentor is sitting on this call today. Hi, Ken. So anyways, I batted around everywhere you could spend time around CAISO metering. I took a nice little technical sabbatical, went to work at SEL for a few years, and then made my way back to the space. So that's me. Mostly that's just important for context. I like to joke that I'm a fake engineer, but I kind of merge the field and desk side of engineering and design considerations of these projects. And so I'm happy to answer any question that I can. And if I can't, I'll just let you know. So here we go. What are we going to talk about today? I like to start with perspective. So just kind of take a big picture look at the landscape around metering, kind of dive in, get a little bit more technical. Talk a bit about the interconnection space from a kind of CAISO data perspective, and that's going to touch on revenue metering, and which when I say metering, I'm mostly referring to revenue metering, but there's also a telemetry component that we'll talk about. And then we'll get into some of the local drama of complexity that Kelsey hit on previously. This presentation is formatted more as like talking points, so it's not really a very useful read-only document. But as Sarah mentioned, if the content on the slide and the words I'm speaking aren't exactly jiving for you, please jump in and ask for clarifications. I want to make sure we bring everyone along with us. If the questions are too big and too hard, we might save them for the end. But yeah, let's keep this conversational and we'll ride through. A little bit more about me. I stand accused of being this guy. Several jobs I've had over the years. My last boss took this meme to talk about me up to the top suite of a big developing company that I worked for. I'm a bit of a spaz, but also for me, this meme is actually just all about the red lines. The conspiracy is real, and that really is just kind of a joke about perspective. When I think about metering, it is a interdisciplinary, integrated, complex problem space. It's basically in no way analogous to the metering that many of us are familiar with, whether you're thinking about commercial, industrial, residential, or whatever. Metering has touch points all over the place. And those points of contact should be coordinated across all of those places. So we can talk about, current transformer and potential transformer inspection stuffs that lead into measurement accuracy. You need to consider rules adherence, and rules adherence can be things like, how is BESS energy defined? BESS is battery energy storage system acronym, commonly used around here. Rules adherence can mean marrying your utility load rules against your wholesale market rules. We've got to think about things like co-located versus hybrid considerations when we design a facility. In that case, you're basically looking at the same exact schematic, but the contracts define participation, where the meters ought to go, and then the meters implement that participation model. We've got different connected systems like controls, specifically in SCADA, which are controls especially is becoming a much more hot button item. So your quote revenue meter might also be part of your closed loop control system that keeps you compliant with some new IEEE standards that are coming out. It's a like the Pepe meme shows, it's a very interconnected space. And then we think about the human interaction as well. So anyways, a lot of times with metering, what I tend to do is I try to start at the endpoint where I need to end up with a problem, and then I start working backwards from there, try to figure out how to get where I want to go. I mentioned war stories or whatever, so I'm going to start with a little war story that just kind of touches on this perspective slide. So once upon a time, I did a hydroelectric facility job, and when I say did a job, I mean, you know, I helped with some design phase. I assisted with the metering integration, and then I acted as CAISO inspector for the project, and I had follow-on support for that project. So just to kind of give you an idea of more of like a full wrap scope in this space, but this project is, like I said, is a hydroelectric project. And if you know anything about California, we don't get a lot of rain. And when we do, it's kind of a big deal. So if you own a big old dam with a 95 megawatt generator and your lake is full and you're spilling, I think the phrase is like water is money or something like that. So you just let the generator run at maximum output as long as you can. You used to do it that way before you operated in the wholesale market if you were a hydro facility, but actually what the story is really about is the interconnectedness of the metering. So let's focus there. This project had 3 different points of metering that were all set up completely differently for different purposes. They had a CAISO revenue meter. I think it was 69 kV, which might tell you what utility that lived in if you're nuanced. They had a sort of HMI operator view of what the plant's output was, and they had a sort of generator control governor type control system. These were all on different current transformers. They all had different devices driving the measurement values into the subsequent systems. And the point of this story is that this is a 95 MVA rated facility. So that per their interconnection agreement, that is the maximum limit that they are allowed to inject into the system. With the surplus of water and head pressure, this facility was actually producing 106 megawatts. That turns into penalties really fast. And you would know that if your measurement systems were in alignment, but they were not. So this project had the symphony of different meters, different technology types. There ended up being a fun issue with just the actual wiring circuit that caused an underrepresentation of the megawatts due to CT burden. Talk about that later if anybody wants to get into that. But the end of the story goes, you know, we get wet years and we get wet years every once in a while, and we get a lot of dry years. And if you're a hydro, the wet years kind of carry you. And this particular project paid their 5 years worth of surplus money back to the grid in penalties because they wouldn't listen. They didn't believe the information that they were hearing about their overgeneration because they were looking at the wrong points of measurements, and those measurements were not appropriately calibrated and accurate for the job that they were to do. So I guess you could look at that problem and just say, or what I ended up saying is, well, you could have just listened to me in the first place when I told you to source everything from the high side. That represents your point of interconnection, and that's the best place to be performing a closed loop control like you are. Anyways, without getting too much more into the war story, the idea is just that knowing where your data flows and making sure that that data reconciles is a very important design consideration for your project. You want your revenue data to perfectly reconcile with your dispatch. Otherwise, you're leaving money on the table or you're paying penalties the other way. You want the people that are looking at historized data or SCADA to have the same values that those other systems are so that they're, again, all systems are in alignment. So yeah, diligent design upfront, data alignment, it's all very important. This is just a slide to kind of tee up where we're going to spend the bulk of our time, just talking about CAISO metering. So you can see what's on the slide. I don't need to read it, and we're just going to get right into it. So CAISO metering 101. I like the Venn diagram because it brings me back to the third grade, and it's a simple visual representation of kind of the problem space. You can see here on this Venn diagram, I think I have maybe types of compliance or stakeholders that you would have on a project. There's a lot of places to go with this slide, but at the beginning, I would say that, there are a lot of overlapping requirements. With respect to metering, you need to thread the needle and be in the darkest blue little portion in the middle there. And importantly, you want to understand these requirements. I usually give the number of before your 60% design phase, because compliance to these different types of requirements has significant considerations for how you design a substation, where you place transformers and metering and such to conform to those requirements. Like I said a couple slides ago, your metering is basically an integration of best practices for measurement accuracy and the contracts that discuss or determine the sale of your energy. So it's not just a meter, it's how you're participating in the market. It's a lot of other things. So with that, and so as an example, if you're getting ready to draft your offtake agreements and sell the power that you're getting ready to build, you want your lawyers and the people that are involved in that commercial arrangement to kind of have a pretty good idea of how you're going to sell your project or sell your project's energy, like before the 60% design phase, because that is going to have a direct impact on how you're going to meter the project. And metering is substation hardware, it's bus arrangements, stuff like that. So you need to have kind of that information, at least in good confidence in hand and in coordination with your design team. Talking about utility stakeholders, and they need to be satisfied. When I talk about utility stakeholders, I mean your specific utility project team insofar as what they say in an email. Unfortunately, utilities bring typically a very thick rule sheet, and there is not strict adherence to those rules. Every project manager or project engineer, and especially if you're on a certain blue and yellow team, your utility technicians bring their own rules, and they're not really in a good position to negotiate as the interconnection customer. So you need to understand the big rules and then the project specific rules with respect to your utility team and be compliant. You also, again, as I mentioned, need to think about how your metering is going to integrate into other systems. So if you're bringing a controls vendor that has a specific technology type or a specific, control protocol that they use, that walking backwards, as I mentioned, that's going to kind of dictate what types of meters you have and where you place them. So to just kind of give a brief overview of who your stakeholders might be, obviously we've got CAISO. This is a CAISO metering presentation. You've got your transmission operator, and the flip side of that coin, very often the same party is the retail billing entity. However, parentheses, retail billing entity and transmission operator are like purposefully separated entities within a utility organization. So don't expect that right hand and left hand to talk to each other. Certain PPA off-takers, especially some of the community choice aggregators, will bring their own sets of requirements to a project. So you need to have those in hand as you're designing your project. The party that you might use for a scheduling coordinator, depending on how involved they are, can bring needs to a project. If you're bringing an O&M company to manage your asset after you're done going commercial, they may have requirements as well. And then I've got environment on there, but that can touch on things like getting your RECs. You might have, we're often talking about renewables, but you can be in a carbon space where the air board might use meter data as proxy for your carbon footprint or whatever else. So again, just really the big idea here is capture all of your requirements, overlay them, and then understand how you can thread the needle to be compliant with all sets of requirements at the same time. Sometimes that means, with a single meter, not so much these days. But again, the overlay of these requirements should be feeding into how you design your substation, and I say 60% because typically at the 60% design phase and after, it becomes really hard to make a significant change to your project. Okay, so sort of the foundation of CAISO metering from a very technical perspective is just good utility metering at each metering point. So the quick history lesson goes something like CAISO was created something like 98, and at that time ANSI, I don't remember what ANSI stands for, but they have requirements for a lot of grid hardware, and they are the sort of all of North America standard. Their standards were basically directly adopted by CAISO, and they haven't moved much since then, the standards that CAISO has. I mean, ANSI standards have increased in accuracy. They're optional. I kind of talk to ANSI compliance. I try to analogize that to like building codes, right? You got federal building codes, you got state building codes, everybody's publishing their standards every year. And the county where you're going to build a house has to choose which ones and when to adopt them. So even though you know, IEEE or ANSI or IEC or somebody is you know, escalating accuracy capability or protocol requirements every year, you really have to look at the people that are regulating or in charge of the space and which of those standards they've adopted. So to kind of give you an example of what I'm talking about here, so CAISO requires a meter that has a 0.2 accuracy class, or what that really translates to is the maximum error tolerance for measurements of the meter is 0.2%. And that was the highest accuracy that you could get at the time. But there is now a 0.1 class, which is twice as accurate. That 0.1 class is certainly available from both Schneider Electric and Schweitzer, the two meters that I have recommended up there. There might be some other folks that are now representing that accuracy class, don't know, but I also don't recommend using many other meters. We can talk about that later if you want to. But another example of increased accuracy requirements from ANSI, so CAISO has long used the 0.3 error tolerance or 0.3 accuracy class for current transformers, that's the CT, and potential transformers or voltage transformers, that's a PT. That's a good standard. However, ANSI has since come out with 0.15, which is again half of the allowable error, so twice as accurate. And then the S that I have on the screen there is extended range. So a 0.3 class instrument is, depending on what year of ANSI standard you're looking at, is good for something like anything from the nameplate rating of the CT or 90% of the nameplate, or sometimes down to 10% of the nameplate and through the rating factor of the CT. It's a little bit technical. You don't really need to know any of that right now, but the point is, what the S means is that it extended range. So there is an accuracy class which will give you that range of accuracy all the way down to 5% of the nameplate rating of the current transformer. And I have on there with proper ratio calculation. So I'm going to talk a little bit about that because it's an often overlooked design consideration. Current transformer is accurate at, is sized for a certain amount of current. Let's just say 1,000 amps. So if it's a normal class current transformer, it's 1,000 amp current transformer. It's good from 100 amps through whatever the rating factor is. Let's say the rating factor is 2, so it's good from 100 amps to 2,000 amps. Your utility, which brings their own set of requirements as a retail billing entity, is not concerned with your wholesale bulk transfer of energy out to the system. They are concerned with the very small amount of energy that comes back into your system when you're not producing energy. And so they want that CT to be accurate even when you're only pulling 10 amps into your facility. So that's like 1% of your sort of CT nameplate, and that's not actually doable under any any CT standard. I think CT standards are C57.13 or something. Anyways, one way to get around that is you can get attestation from the manufacturer that it is actually 1% accurate. But the main way that you want to get around it is by actually sizing your CT exactly right. There is a calculation to do so. And while CAISO may not have a requirement that you do that calculation, many utilities are starting to bring that requirement on board. So again, back to the Venn diagram, you need to meet all requirements. You're gonna have to do some math to start throwing CTs around in your bus arrangement. It's not and I'm specifically mentioning this because a lot of design engineers and design firms are protection and control focused, and the CT consideration for a protective device is completely the opposite of a metering device. So I very often have to chime in with recommendations and assistance on how to accurately capture the current that's being used to measure settlement energy for a project. That was a bit more technical than I intended. Sorry about that. Probably lost half of you, but I'm gonna keep going. Potential transformers kind of have the same thing. They've gotten twice as accurate. There's no calculation because there's not much range, but there is a way to get the ideal burden for a PT. And all that means is don't go for the highest burden rating because nothing has any burden anymore. So you're probably at the worst accuracy within the spec of that CT. And the punchline here is really that your current transformers, your voltage transformers, and your meter, they all have error tolerance, and very few things read high. So any kind of specification error or design error that you make is just things are going to read lower. Your megawatt and megawatt hour measurements are going to be lower than what's actually there. And even if it's fractions of percent over the course of a 20-year life of a project, you're leaving a lot of money on the table by just not being specific about how you design your metering rotation. So we're all here to make money. We want to help you make the most money you can, and that's just good, diligent design. While we're on this page, though, let's talk about that bottom set of bullets, which is verifiability. So again, we're exchanging millions, sometimes billions of dollars of energy over the life of a project. You cannot buy a gallon of gasoline without independent inspection and verification of the measurements of that pump, and even the thing that calibrates the pump has to have traceability. And all of that is perfectly analogous to the way we do metering. So in terms of saving money in a design space, a lot of folks like to think about, oh, I've got a transformer that has a couple of CTs I'm not using in a bushing, or I've got a breaker somewhere that's got bushing current transformer space that I'm not using. I can just stick my metering stuff there. Sometimes that works. I'll just go ahead and say, if you're thinking about putting in a transformer, don't. I've never seen that work well, not one time. Circuit breakers, it depends, and it just depends on how accessible the current transformers are. But the point is, and I'll get into this a little bit later, it needs to be verified. That nameplate needs to have your utility, your CAISO meter inspector, which I'll talk about later, needs to be able to physically touch, access, and document your entire metering installation so that it can be verified to be compliant with all of the applicable standards, and so that it's traceable, so that if ever there's a dispute, everything's above board, right? And this may not sound like a big deal, like whatever, we can just work through it. But if we're talking about CAISO metering, this is a CAISO requirement that your inspector be able to access the stuff and perform all the associated tests. Yeah, what you don't want is CAISO to tell you, yep, we don't care that you put it in your transformer. You need to let the inspector tear apart the bushings, access the CTs and PTs, get into the transformer control cabinet, get into all the circuitry in there, and then trace the circuit all the way back to your meters. That's, all of the costs that you think you saved by sticking the CT there, you just lost 10 times out of 10. So yeah, CT, PT placement, accuracy, it's all very nuanced and all very important to maximizing your likelihood to get in a commercial project and the long-term revenue stream of your project. Extended cut on good utility metering practices, some things to think about. And again, this is in the context of your project-specific compliance space. You can put meters in cabinets, inside or outside, with a lock on them. You can put them in a relay panel, open back, just like any other device in a substation. With respect to your metering current and voltage transformers, you can do a home run, which means single piece of wire from the terminal of the transformer all the way into the first test switch block of the meter. Or you can go, again, what protection control folks like to do, and land in a marshalling cabinet and use your cable tray up top. The first two bullets are pretty well related from a metering perspective and the nuance of that game. There are circuit security concerns. So if I can access the circuit, in theory, I could increase or decrease the current or voltage on that circuit through a number of fairly simple means and influence that metering outcome by doing so. Subsequently, there are people that are very concerned with the circuit security of metering wires. CAISO rules formally are actually very strict on this. However, understanding that they work in a real O&M environment of operating power plants, the interpretations of those rules are relaxed. But if you want the safe play, CTPT home runs straight into a cabinet, which is not accessible. So the wiring is not accessible anywhere else. What can you most reasonably do? You can put your circuits in marshalling cabinets, and you can mount your meters in panels, but keep in mind that there's audits, there's routine inspections, and these things can come up. So design considerations. Some definite no-nos: shared test switches. Again, we don't want someone to be able to shut off the utility metering because they need to access CAISO metering. We don't want the CAISO inspector to interfere with utility metering. We don't share devices that interrupt circuits, except for those which are not meant to be normally used, like a terminal block. I have terminal blocks on there. For all you green design engineers, there are terminal blocks that are for current transformers. They're shuntable. Don't use a non-shuntable terminal block, please. Please. I put fusing on there with a question mark. Fusing from a revenue metering perspective is a good way to protect your meters. It's also a good way to lose a little bit of money. I've found partially blown fuses a couple of times, and what that means is there was a little surge, didn't pop the fuse, but the fuse has now become slightly resistive. You're dropping a couple volts, maybe 3 volts is 2.5% of your voltage on that phase, and that means that your watt hours are 2.5% less on that phase. You're losing power. So there are ways to look for that. That gets into like a SCADA consideration, where your metering touches alarming and data and stuff that you can do. Talk about that later. But yeah, design considerations around metering touch everything. I used to be a really big proponent of, CAISO meters are basically the best meter that you can buy. And so why would you want to leave stranded capacity there? There's all kinds of things that you can do with the kinds of meters that we use for CAISO. They are sometimes the best digital fault recorder on a facility. They're a great place because of their current transformer placement. They're typically perfectly compliant and not involved with protection schemes when it comes to things like synchrophaser data. As I mentioned, they're often involved in control schemes, but there's a thing to understand about jurisdiction there, such that CAISO has jurisdiction over those meters, and they are that jurisdiction in terms of maybe time synchronization or password protection does not marry well with some of those other ancillary applications. So if you're doing controls, I would say correctly, and using a purposeful controls protocol like synchrophasers, you need a 1 millisecond time synchronization all the time to any device that produces data on that protocol. You cannot have that kind of time synchronization on a CAISO meter. It's just a conflict of rules. So now I am a big proponent of owner's meters. You can have them mirror the CAISO metering, or you can use them for every other purpose that you would otherwise use a CAISO meter for, but shouldn't, because you want to sort of island the CAISO functionality and keep it in its own little safe space. Yeah, we could talk a bunch more about what those functions might be and how to implement it, but yeah, I think I have somewhere in my notes that this 2-hour presentation is a distillation of like a week that I do at up at the Northwest Metering School. Shameless sponsor plug. So if you really want the deep dive, come find me up in Seattle every August. It's the best weather week in Seattle, and they probably have the best beer in the country. So come find me. All right, so I've thrown some terms around, and I'm going to try to get in and describe them a little bit better. So I know Kelsey mentioned it previously, but there is a CAISO meter inspector. So what that basically looks like is CAISO does not hire or employ or whatever utility type folks. They certify folks to do that work. The developer or someone under the developer's umbrella will hire that person. So we're privately hired. I say we because I'm a CAISO inspector myself. That person's job is to act like a utility meter person and verify all of the things about that metering application are compliant, not just to CAISO's rule set, but also to your specific CAISO accepted and approved project deliverables. So in bucket 1, as Kelsey mentioned, you're going to submit a single line and a 3-line drawing and a COM block drawing. Those are basically schematics about your specific site, and then CAISO is going to approve those specific schematics. Subsequently, the CAISO inspector's job is to make sure that what you built is actually what you proposed to build and got approved by CAISO. So if you had a procurement issue and changed your CT ratio, or decided that based on some updates to your PPA, you're going to move a CT location somewhere, that CAISO inspection is going to fail. And what all that really means is that you're going to need to update and get approved schematics that match what you've built, so that the CAISO inspector can say, yep, what's on the drawing is what's in the yard. That's with respect to the physical installation. Again, current transformers, voltage transformers, the circuits that connect them to the metering. And there's a thing called burden, which just basically means as you've applied a CT and PT, you're not using too much cable length, too small of a cable, your terminations are all good, such that those transformers, which are very low power, very high accuracy devices, are able to transform power without having to really push through a load. The other component of a CAISO meter inspection and the duty of the CAISO meter inspector is to understand the meter program. As I mentioned, these meters that we put in substations are almost 0% analogous to the meters that live on your house, on the side of a Walmart, in the agricultural field, or wherever else you might find a meter from a logical implementation perspective. So they're going to have a bunch of different industrial protocols where they stream data to other devices. But importantly, they also, the logic, unlike any other meter, these meters, you're able to intervene with the processing of the meter between its measurement of voltage and current and its recording of energy. And again, just like the idea that your circuit needs to be secure, the program needs to be secure. We need to be able, as an inspector, to assure that you are not crediting yourself or creating special conditions where the meter acts differently than normal, unless that behavior is approved by CAISO. A specific example of where that might take place is a thing called BESS idle, which I don't even think I have in this presentation, but I'm sure we'll talk about before it's over. But kind of the punchline there is, as inspectors, we either need to reverse engineer what you've done in a meter program, or we can have some role in the design aspect in the first place, such that we're able to understand what's going on logically or from a code perspective inside of the meter, so that we know that what's being measured is accurate and is what is agreed upon by CAISO and the other pertinent parties. So There's a program inspection, there's a physical inspection, and all of that should take place well before your point-to-point test, as Kelsey mentioned. We'll get more into point-to-points in a minute, but I really want to hammer on this role of the CAISO inspector. It's as far as I can tell, because as I mentioned, I teach utility guys at a metering school up in Seattle. What we do here is much more in depth than what most other utilities do, because the dollar amounts and the energy volumes are much higher. It's just much more important. So that's who the CAISO inspector is. As I mentioned, you might have a single utility that is your transmission operator. That's a NERC term. They might also be your retail utility. Again, those two folks don't talk, but they might wear the same shirt. I'm wearing a polo shirt. Everybody wears a polo shirt these days. So two people that work at SCE or SDG&E or PG&E may be from completely different departments that aren't even legally allowed to have overlap. So you need to be managing those relationships. Another very important person in the game, and I probably missed Kelsey already talking about this, but scheduling coordinators. Importantly, for the metering perspective, their data can be part of your metering scheme. So I guess I said I was going to talk about Best Idle. Let's talk about it right now. The scheduling coordinator is the party that has access to the ADS or automated dispatch system that is part of the CAISO data system. They basically have a secure website where they post your dispatch, and only a scheduling coordinator is able to access that information. So your dispatch status for a battery facility has a direct implication about how data is recorded in the metering. There needs to be a data path from that ADS server through your scheduling coordinator into an industrial protocol and into the meter to determine how the meter records whether you are acting on a wholesale dispatch, and if you're not, your loads become a retail problem. And we, per CAISO tariff, those two things need to be distinct and separate, and we don't want essentially double billing in the metering. So your scheduling coordinator is an important person from a CAISO metering perspective. I know Kelsey mentioned it, and I'm going to mention it a little bit later, but there's also a thing called scheduling coordinator metered entity. And in that case, they're going to be the only person that is able to submit your settlement data to CAISO on your behalf. So all the metering stuff that we're talking about here is still applicable. It's just that the path to settlements is a little bit different from an SCME, scheduling coordinator metered entity perspective. So depending on the complexity of your site and your data needs, make sure you're selecting the correct SC. Some of them have a more complex role, some of them less so. I lost my mouse. There it is. And then I know Kelsey touched on it, but I think I probably got asked to hit on it again at some point, so I'm gonna. EDAS is an engineering team, EDAS, Energy Data Acquisition Systems. They're an engineering team that brings operational and settlement data into CAISO systems. NRI is a process management and compliance team. Surprise, EDAS is the engineering review for NRI, but they're still completely different teams. Please, please, please do not ask the energy data folks to help you with your NRI stuff. They will not like you. Neither will I. There was something else I was going to hit here, so I'm just going to sit here and be quiet and think about it for a minute until it comes back to me. Nope, lost it. Have to come back later. So I've been talking everything about revenue metering. Oh, I just remembered it, and it has everything to do with this slide. Especially in the NRI process, new resource implementation, we talk about the full network model. And everyone worries about full network model implementation dates, and they drive your whole project schedule and all this, but I don't ever hear anybody talk about what the full network model is. And that has actually everything to do with your rig. So a rig is a remote intelligent gateway. It is approximately an RTU, except it works on, in terms of how it interfaces with CAISO, it's not a serial connection. That's an RTU. It's an Ethernet type connection, or it communicates over an Ethernet type data path. So it's networked. Also, locally or behind on your facility, there's a lot more networked traffic typically into a rig than there is into an RTU. That's more about compliance and convenience than anything else. But importantly, what the full network model is the way CAISO comes up with what your dispatch is, the way they come up with what is the pricing at a particular P node that you might be connected to or scheduling into or whatever, is they have a model, a computer model, the entire electrical system, at least transmission system, and every point of contact with that electrical system is modeled into that computer model. So your new facility is being added to a computer model of the grid. And from your facility, and as part of your modeling into the full network model, there are variables that populate the model and help the model understand how much current is flowing from where to where. Is there a frequency problem? Is there a voltage problem somewhere that CAISO needs to start dispatching to correct for? And that full network model is populated basically by two things. ICCP data, which Kelsey mentioned previously, which means inter-control center protocol. So this is like a utility to utility type protocol. And within CAISO, that's mostly load data from the utilities. But within EIM, that can also be your generator's data. You're feeding your generator to that utility, and then they're going to add it to an ICCP list or points list and feed that over to CAISO. The other way, within California or any approximately in California resource, a resource with a rig, that rig is the data exchange into CAISO's full network model. It passes through EDAS and then into the model. So when CAISO is concerned about whether or not you've actually, verified from a originating device, I'll come back to that term in a little bit, the data that is going to flow into the rig and into CAISO's systems, they're worried about that because if you give them bad data, the result of the whole grid simulation is going to be wrong. And then they can start dispatching wrong. Like lots of stuff can go wrong. So it is very important, even though it's not your settlement, that your telemetry data is tight and right. So just as kind of to overview that, since I kind of got serious there for a minute, what a rig does is it collects a bunch of data from your site, it bundles it nicely into an agreed upon format with CAISO, and then it serves that data to CAISO. I'm using serve in both contexts. It's technical and not technical. You're a server to CAISO. It also brings a limited amount of data from CAISO back to your site. So if you're the type of site that participates in ancillary services such as automatic generator control, AGC, that data, you will be told from the ADS system, think back to your scheduling coordinator slide ago, hey, you're now on AGC dispatch, and then that AGC information will come from your CAISO rig, and it needs to find its way pretty quickly into your plant control system. One of the things I like to hammer on is please use a dedicated device. This gets back to the same thing I talked about with revenue meters. You could use a substation RTAC as a rig. You could probably use a Raspberry Pi cell phone or something as a rig if you got it approved. But what you really want is just a super robust, dedicated device, because you don't want to have to make an update to a point that you're bringing in from a relay because you forgot to add filtered frequency to your SCADA map. But that's also your CAISO rig, and now you need to take an outage and do fieldwork coordination with CAISO. So digression there. CAISO has a left hand and a right hand that don't touch or don't talk. They probably touch, but whatever. You have outage management, which is, this is back to the who bill slide, but you have outage management at CAISO that they manage device outages, data outages, energy outages, and every kind of outage that you can imagine. And then you have field work through EDAS to work on CAISO jurisdictional devices. And these are two different teams that don't coordinate well, or it's not their job to coordinate. It's our job to coordinate betweenst them and schedule appropriately. So yeah, use a dedicated device, because the situation you don't want to end up in is needing to make simple or complex updates to a device that for other reasons than serving CAISO their data, because it really the CAISO compliance and outage component really gets in the way of your ability to just freely operate and manage your facility. Check my notes, make sure I hit everything. Yeah, so obviously, I guess the last thing to touch on maybe is, with CAISO revenue metering, you are required to use a CAISO meter inspector if you're a CAISO metered entity. There isn't an analogous requirement for rigs, but it is still recommended. There's a few shops in town that they specialize in CAISO telemetry. They have higher levels of expertise, both specific and non-specific to these problems. And just speaking from experience, I've seen a lot of less experienced, less dedicated folks have large impacts on project timelines just because they volunteered to do services they weren't expert at. So strong recommendation, use dedicated folks that know the space, just as you would for your metering. This data is just as important as your meter data. So here we go. We're going to talk a little bit about CAISO metered entities versus scheduling coordinator metered entities. I know Kelsey touched on that in the previous presentation. I don't know how many of you from this presentation were in that presentation, so I'll give you my quick version of it. CAISO ME, that just basically means that CAISO is pulling your meters directly, and they perform all the subsequent processes such as verification, estimation, editing. So, if you have revenue data, all that circuit and meter and program and everything's all been super inspected, it's great, but things go wrong on site. So you want to do some sort of verification against another data point. Maybe it's against your dispatch, maybe it's some gross data from a relay or some, wherever the data comes from. You want to do some comparison to make sure that your data lines up. Where you have gaps or issues, you want to have a different data set that you can estimate from. And then as you need to edit the data that's erroneous, right? That's the VEE process. If you're an SCME, somebody in that process needs to be doing that VEE function. CAISO does it as part of the CAISO ME function. So it's a fairly complex thing to do. It's very specialized. CAISO does it, I don't want to say for free, but as part of their wrap. Another thing they do as part of their wrap is Regis reporting. So many of the resources that come into CAISO have a significant portion of their revenue stream that comes not just from the energy exchange in terms of watt hours, but in terms of renewable energy credits, RECs. And those come from this place called Regis, which is somehow related to WEC. In any case, if you're doing CAISO metered entity, CAISO will act as your qualified reporting entity for Regis. That's part of their full wrap. If you're doing scheduling coordinator metered data, you need to find somebody else to do that if you have renewable energy credits that you can obtain from your energy. As Kelsey mentioned, there's an important component of CAISO acting as an impartial third party. That's actually kind of the whole reason in the first place for CAISO having CAISO ME participation and having CAISO inspectors is that at least in the earlier days of CAISO, there was an acknowledgement that you basically have a independent powered producer seller and typically a load serving entity utility buyer, and they are on either side of a transaction, and each party has an incentive to skew the energy settlement data associated with that transaction. So the only way to make sure it's done fairly is to have an impartial third party. That's where CAISO comes in, not as a grid operator, but as a market operator to make sure that everything is fair and clean from a transaction perspective. So they don't have any interest either way in the transaction. They do make a great impartial third party. There's a number of reasons why CAISO has opened the door for generators to participate as scheduling coordinator metered entities. So that participation model used to only be available to load serving entities. However, with the types of interconnections that folks are building these days, we've sort of hit a complexity limit on what we can actually implement under CAISO ME rules. So there's a necessary relaxing of the rules to allow these very complex installations to be metered appropriately and have that data submitted. So the SCME platform offering more flexibility behind the data submission. It's a good platform for that. There's also things like DC metering, which is coming into play, which, CAISO is never going to approve a DC meter for a number of reasons. We can talk about if anybody wants to ask. But if that's part of your metering scheme, again, you're in that more flexible participation model of scheduling coordinator metered data. There's some other freedoms. I probably don't know what they are and don't care, but things like you don't have to necessarily use a CAISO approved meter if you have another technology preference. But with SCME, the other thing I like to bring home is the regular testing and auditing requirements are actually much higher than CAISO metered entity. So because you're getting a kind of relaxed data submission rule set, there needs to be better verification, like ongoing verification that the data that is being submitted is still appropriate for settlement in the CAISO market. So whereas in a CAISO ME sort of paradigm, you basically can put a meter in, and unless your PPA says that you have to test your meter, you don't really have to. You should. And also your audit risk is very low. But in an SCME participating paradigm, auditing is just like regular auditing is just part of the process. Like build that into your budget and your schedule. Likewise with regular testing of all of your devices. So we're going to get into like DC metering and stuff and complex metering in just a minute. But yeah, these things are a bear to test. And if you're participating as a scheduling coordinator metered entity, you got to do it and do it often.
So Pat, we have one question that came through.
Bring it.
Do we need to finalize the number of revenue meters?
Says, do we
metering
need to
scheme and
finalize
data
the number of
processing?
metering scheme and data processing calculation before signing a PPA, and all language and formulas need to be included in the PPA, or is that more of a 60% design consideration?
I'm apologizing to the audience. I had online and offline audio at the same time, and my hearing already sucks. Sorry, war stories. Kelsey, could you do that again, please?
Do we need to finalize the number of revenue meters, metering scheme, and data processing calculation before signing the PPA, and all language formulas need to be included in the PPA, or is it more of a 60% design consideration? So
yeah, so thank you for the question. I'm not going to reread it because I can't see it, but formally, your metering does not need to be established until you've hit the issued for construction design set. So that is the design set. The only design set that CAISO is going to review and approve. It actually has to be issued for construction and stamped by a professional engineer in order for CAISO to even look at it. So according to the requirements, that's where the need to identify which meters and where and how comes into play. What I'm trying to stress is that because there's so much interwoven contact between how you should meter a given power purchase agreement, for an example, or how you should meter a project given its power purchase agreement, that you need to start fleshing these things out at 60% because design starts to become very inflexible at that point. Hopefully that answered the question. If not, let's talk a bit more about that in depth at the end, and we'll just have everybody come off, and we can talk about it live. Yeah, so big theme in California ISO metering these days, and this is on both the CAISO metered entity and the scheduling coordinator metered entity space, is complex metering schemes. Usually this is where I go whiteboard and have fun, but I don't have a whiteboard and I didn't make a drawing. So we're just gonna talk through it. Everyone's gonna close their eyes and get all Bob Ross for a minute, imagine stuff. But essentially the simple problem statement is the point where you're measuring energy is not the place where you're selling energy. And there's always going to be some loss of energy between those 2 points. And hopefully it's nominal if you have a simple installation where you're, a good golf swing away from the substation and your whole project is selling power to one off-taker. you probably have no losses and you don't have to worry about complex metering schemes. But as soon as you have a single interconnection where you have two power purchase agreements, sort of sharing interconnection infrastructure, or you have mixed fuel types participating in a co-located or a hybrid type scheme, the metering gets complex. The punchline, and we'll work backwards from there, is the energy that is recorded in the meter needs to represent the energy delivered at the point of delivery for the resource that that meter is representing. So if you have a transformer high side meter and you have three resources behind it, there's no way that that transformer high side meter is going to know which energy is attributable to which resource. You have to meter far enough back into the facility that the energy from each resource is distinct from the other resources. I've completely gone off track with my notes here, so let me just make sure I'm not missing anything. Yeah, the problem here is losses typically. So you have a long transmission line between you and the grid. That's going to consume energy. Those losses need to be subtracted from the energy that you're measuring way back at your 35 kV bus. Likewise, there's a transformer that's also going to consume power. Those losses need to be subtracted from wherever your point of measurement is, if it's between that and the point of sale. Utilities are supposed to treat everybody the same, and they mostly do. So when we talk about station service, when you are net energy into the grid, asterisks, those station service loads are netted against your gross energy, and you report the energy that actually makes it to the point of interconnection for your resource. So that energy is more energy in addition to line and transformer losses that need to be subtracted away from your point of measurement. And I'm talking about 35 kV because it's the most common medium voltage in our projects, and often that is where energy is distinct from one another. So Kelsey gave the example of a 500 megawatt resource. It's fairly common size these days, and 100 megawatt PPAs. So you could have a low side bus with 5 feeders. I guess with new NERC rules, you would still do that 100 megawatts a piece. And yeah, so you're going to have 5 meters, one representing each resource at the 35 kV position, probably on a feeder breaker. And then you're going to have a big old transformer and a transmission line and some station service load between those meters and your point of sale, point of delivery, point of interconnection, point of common coupling. All of these things are often analogous, but not always. But the point of delivery, point of sale, essentially, is where all of the data at 35 kV needs to reconcile to. So often up at like 230 kV or something like that. And the important thing to know is that from a specific 35 kV meter position, that meter cannot know what the current is of the other 4 meters in which it is sharing the facility. So it cannot accurately calculate what the electrical losses are up to that point of delivery. So what you need to do instead is build some kind of complex metering scheme to solve for each resource meter at that 35 kV position, typically delivering some energy to that point of delivery up at 35 kV. There's a few different methodologies that you can use. I've got them listed there at the bottom, but again, starting further upstream than that, working backwards. Whichever methodology you choose, there are methodologies with more or less error. The market does not carry the error. Your resource does. So if you choose a more cost-effective in the development phase option, like a static loss that I have listed, you're going to have to overestimate your losses, and you carry that. You're basically getting paid for less energy that you're delivering because you're using a less accurate method of measurement. An important adjacent item to keep aware of is that there's lots of fancy ways to do this. I've heard people talk to me about, using different types of database and energy tagging using what's the Bitcoin technology that everybody uses? Blockchain tagging or whatever. There's all kinds of creative ideas that you can come up with. But there is a choke point in the system, which is a standard revenue data collection system that's typically MV90. MV90 is multi-vendor, 1990. That just means it is a system that can read anybody's meter, and it was developed in 1990. So we're using a Check's Watch 34-year-old system to collect our revenue data. And the other piece of information that's important to understand about complex metering is that, you have a 5-minute energy interval that's associated with market pricing and dispatches and everything else. But in the middle of that 5-minute interval, you're going to have different resources ramping up, ramping down. You're going to have cloud cover over PV. You're going to have intermittent wind across your wind resource. You might have AGC dispatches on top of your regular energy dispatch if you're a thermal or if you're a battery resource. So the granularity of activity of any given resource is smaller than 5 minutes, but you have to represent that data in 5-minute intervals in order to serve data into the multi-vendor data collection system. So you're trying to, oh, I see something and I can't read it.
Yeah, we got another new question from Jitendra.
Yeah,
line.
Let me hold that one until I just
Okay.
let me get through the end of this slide, and then if I don't know what the question is, but if I don't hit it, then let's jump on that question before we move to the next one.
All right.
So what I wanted just to do is just talk about these methodologies real quick. So you have, again, we're trying to take a meter that can't see parallel activity on shared infrastructure, but it is trying to represent its activity in conjunction with that other activity and the shared interconnection infrastructure and represent energy actually delivered to CAISO at the transmission system point of interconnection. And you can do various engineering methods to take that, to make those calculations at 35 kV or whatever low side voltage you have and represent that point of interconnection. You can do a static loss, so that's just a set percent. Figure out what you think the losses are in the worst case scenario. 5%, you just take 5% off of all of the energy that you deliver to CAISO, static percent. You can get a little bit more nuanced than that and try to figure out what the worst case loss is and represent that as like an impedance curve. It's a little bit more accurate, but again, you're assuming everybody else is doing the worst thing that they could possibly do to affect your losses. There's a thing called peer-to-peer, which is the most common application, which is where all meters kind of are in a communication scheme with one another. And what they basically do is they solve the entire solve for how much energy is being lost and where, and how it's attributed across the entire interconnection. And it does this in real time, once every few seconds. And since energy is just power integrated over time, you have a real-time updating POI representation at each meter point that you can drive into an energy value and settle upon. And then I have a wild idea that actually you could really, we have so much data recording capability these days. You just record really short intervals if you're in an SCME type application, and then just do all the calcs in a database, and then aggregate the data up to the appropriate interval size that you need to actually submit to CAISO. I haven't gotten anybody to bite on that one yet, but I think it's the most robust way to solve this problem. I probably have a few other things to say, but I've lost my train of thought. So let's go hit that question real quick, if you would, Sarah.
Of course. So Jitendra asks, is the GenTie or the line tap to say 132 kV or 345 kV line, will that be considered as the POI, or is only delivery till the substation considered as the POI?
That's a great question. So typically the point of interconnection, well, I guess almost always, and Kelsey, you can shake your head at me if I mess this up, but your large generator interconnection agreement is going to stipulate exactly where the point of interconnection is. Most commonly, it is at the fence line of the transmission owner's substation or switch yard. So you're going to have your privately built or privately developed generation facility. You're going to have some kind of tie line, whether it's, like I said, a couple hundred yards or 50 miles if you're out in New Mexico. And the energy that you deliver is not the energy that leaves your facility. It's the energy that enters that transmission owner substation or wherever that point is as described in the LGIA. So you can typically find the POI described in the LGIA. It's a nice little search term. And what we're really trying to do is capture all of the energy lost between that POI, wherever you need to put meters to represent each individual resource. That answer the question pretty well, hopefully. I guess I don't get a thumbs up for this, so we'll just keep on trucking.
Thanks, Pat. I'll let you know if there's a follow-up.
Yeah. So I know this is super complicated, and I don't have my whiteboard to really get into it. But my colleague Casey James has done some pretty cool case studies that kind of talk about these different methodologies and their, pluses and minuses in terms of benefit to your project and what types of different, resource mixes may or may not benefit from a simpler implementation of complex metering versus not. So I encourage you to hit them up. Yeah, but the punchline, I guess, to this slide is if you have a very complex interconnection, meaning you have co-located resources, hybrid resources, multiple PPAs, in terms of long-term revenue streams to your project, the cost of implementing a more complex peer-to-peer scheme is the industry norm.
All right, Pat, we've got a follow-up question.
Oh, hit me.
So the POI is as described in the LGIA. Can that be different than defined in the PPA?
It shouldn't be. I'm not at all versed in contract law, and as much as I try to influence the way PPAs get written, I've actually had zero success in that. So I really couldn't. I don't think I could answer that question, but I would point you back to one of my first slides, which was probably written in angst, but essentially what I said is your commercial folk that are negotiating PPAs should have an awareness of what the market rules are when they draft that PPA language, because the market rules are always going to trump your PPA language. And what that was really getting at is, especially in the early days of battery systems, it had a lot of very odd definitions of how energy was going to be transacted coming from these commercial negotiators, and those definitions just don't line up with, like, for example, a utility retail tariff that describes when energy is applicable, or how they apply station service netting rules broadly to be fair across all resources and all developers and whatnot. So I haven't seen those points differ between a PPA and an LGIA, at least in terms of the way that the metering implementation works. I'm sure it could happen somewhere, but I could not even hypothesize what that arrangement might be to lead to that. So, all right, I think I'm actually behind on time, which is amazing because it's only supposed to be a 40-minute presentation, but here we go. Some fun pictures for you. These are straight out of CAISO documentation so that I don't have to negotiate with people about the right way to do things. But when we talk about this is getting into, I guess the background for these next two slides is, you get studied. If you want to build a project, you get studied. You get an interconnection. We got a lot of old solar interconnections. We got a lot of people that went into the study process thinking that they were just going to build a solar facility, and then what you realize is that that solar is only using the interconnection 50% of the time on average. And so you can add a battery to that interconnection for basically no infrastructure cost and no study cost, and you can use that interconnection more of the time by letting that battery operate either in conjunction with or before and after the solar facility that's there. So there's two different ways you can couple renewable resources with batteries, or really you can couple of different technology types, but predominantly we're talking about PV and BESS. Traditionally is AC coupling. This is analogous to like lining up thermal units or whatever else you want. It's normal. AC coupling is typically integrated by metering feeders. So you're gonna have some feeders that have BESS batteries on them. You're gonna have some feeders that have solar on them. If depending on how your PPAs flesh out, you might arrange your bus so that you can kind of place CTs across the bus in such ways that represent different fuel types and different resource types. You get 4 or 5 resources, maybe you get 6 or 7 metering points in a substation, and you're kind of done. It's the simplest way to meter because basically the entire resource is already transformed to, or already represented as AC, and you can kind of fit the whole resource energy behind a single meter, or maybe multiple meters if you've got feeders or something going on. As the number of resources and metering increase, the scheme complexity increases, obviously. You can get into SCME situations with AC coupling, but not as often. It's not as scary. It's pretty fuel type agnostic. It's kind of the way we do it. I think the important thing to note, though, is one of the things the slide is talking about is, and as I mentioned earlier, you can have the exact same schematic, and your how you offer your power commercially and how you participate in the market is going to kind of dictate, are you co-located or are you a hybrid? Same exact facility. In fact, you can transfer them back and forth. You got to go through process, but you can do that. Your controls and your metering requirements are going to be different. What CAISO is always going to say is you need to meter the variable energy resource, because part of what CAISO does is try to correlate. They have a model that correlates basically renewable energy fuel, like sun, wind, etc., into how much energy that fuel produces. They have a model that does that, and subsequently they have requirements about metering your variable energy resources, even when they're behind a hybrid resource configuration. On the AC coupling side, that's not really anything that needs to be harped on too much. It's pretty easy to implement, but on the DC coupling side, it's usually a pain in the butt. And the reason it's a pain in the butt is because every controls vendor I've ever seen that wants to DC couple a battery with a PV or something, the thing that's hard to control is the battery. So that's where they put their DC meter so that they can know what the battery is doing. Usually it's on the wrong side of that DC to DC converter because they really want to look at just the battery. When it comes to DC metering, CAISO is going to tell you that you still need a DC meter on every solar input to meet that VER requirement. And then from a revenue metering perspective, you need to have analogous measurements between the solar and the BESS in order to be able to separate them out appropriately. So you need a meter on the same side of the DC to DC converter as the PV, as is shown on CAISO's drawing here on the left-hand side diagram. If you're participating as a hybrid, again, your controls folks are still going to want the meter where they want over on the battery, but CAISO is going to tell you that you have to have a variable energy resource meter everywhere that you've got a DC bus, I guess is what you would call it. So DC coupling, I'm just going to tangent for a minute. I probably shouldn't for time, but whatever. Basically, it allows 2 fuel types to share a lot more infrastructure than an AC couple. And it lets you capture basically free energy. So what I'm talking about here is you've got the medium voltage transformer at each inverter pad that is now shared between twice as much market transaction or whatever. You've got all of the medium voltage cabling from your array into your substation, all of the substation protection control, the inverters themselves, all of this stuff is now shared. So you're getting a lot more bang for your buck in terms of the infrastructure that you're putting in and the resources that you can stick behind it. So you have less capital and less O&M cost to build the same amount of PV plus BESS in a DC coupled configuration as you do in an AC coupled configuration. And then what I actually think is the big deal and what should be catching more regulators' attention than it is this thing called clipped energy, which basically means you design a facility to be able to meet a certain megawatt threshold, and you have to look at your worst case scenario. So if you're PV, you got to look at, okay, what's my lowest sun day? And I need to be able to hit a certain amount of megawatts for a certain amount of time for that day. And the way you do that is by having more DC energy available than you can shove through an inverter and deliver to the POI. What you do with that extra energy in the summertime, when you have way more solar energy for a lot longer, is the term is clipping, but you just basically throw it away. In a DC coupled arrangement, you don't throw it away. You take all that extra energy and just dump it into the battery that's just sitting right there on the same DC bus as your solar. It's basically you're capturing a bunch of free energy. And in the summertime, it's not a small amount. It's more than 10%. It's not.
Hey,
nothing.
Pat, we've got another question.
Yeah, let me, same as before, let me just bang through this slide real quick and then
Sure.
we'll grab it before we move on to the next. So, but in these DC coupled configurations, there is a very unfortunate choke point, which is typical inverter sizes is 3 MVA. I think at the last trade show I went to, I saw one that was 5 MVA, which is significantly bigger. But in the context of projects being 500 megawatts, that's a lot of meters, and you need 2 per inverter, as you can see on the slide here, if you're going to be co-located. So for context scale, I was involved in a 500-ish megawatt project, of which I want to say 350 megawatts of which was DC coupled. There were 420 meters that had to be involved in one of these complex schemes at that facility. And because it's DC coupled, you have SCME testing requirements coming around every year. You've got 420 points of failure in the system. Long story short is trying to revenue meter a DC coupled facility at scale is not advisable because of the requirements placed upon it. So I think I hit everything else in my notes. I guess the other thing I should say before I get to the question is in California, our utilities have essentially ruined the opportunity to DC couple because the PV and the BESS, which share this infrastructure, are considered distinct resources. They are distinct business entities from the utility's retail billing perspective. And there is no way to decouple the energy that those resources consume, the shared energy that they consume from one another. So you cannot perform retail billing on a DC coupled facility under utility retail billing tariffs, which are established by the CPUC, or at least agreed upon by the CPUC. So if you want to do DC coupling in California, I have no idea how you're going to do it, but you're not going to do it inside of any of the investor-owned utilities service territories, as far as I can tell. There's a few other things I can say, but I'm already short on time. So Sarah, you want to give me that question, please?
Yeah. Is grid charging possible with both AC coupled co-located and AC coupled hybrid?
Yes. Most of the time, the thing that comes into play there is what kind of tax incentives that you got into when you started the process. I think those have mostly bled out of the system for new projects at this point. I might be wrong about that, but yeah, that's from a CAISO perspective. You're just going to tell CAISO what's the maximum energy that's going to come out of that facility, and what's, from a battery perspective, what's the maximum energy that's going to come into that facility. That's kind of a hybrid perspective. From a co-located perspective, you essentially need to think about each resource as being distinct from one another from a energy reporting perspective. So even though electrically energy is going to flow from high voltage to low voltage, and if you're charging a battery, that means that PV at your facility is going to flow straight into the battery. The way that energy is represented through that complex metering is as though the energy makes it up to the POI from the PV they're selling into the market, and the battery is buying from the market at the POI back into the facility. The losses, if they're calculated live, like I talked about it in a peer-to-peer consideration or a peer-to-peer implementation, the losses are actually reduced significantly by grid charging, because in a peer-to-peer application, real losses are applied to the metering. So if you have less energy flow through transformers and transmission lines because the energy is actually flowing across your medium voltage bus, that reduction in losses will be reflected in your settlements. So bifurcating between electrically and participation thinking is an important part of that answer to that question, but absolutely it's just part of how you register your battery resource in terms of can you charge or discharge, whether you're co-located or hybrid. I guess if you're co-located, the battery has no option but to charge from the grid from a market perspective. So
Great. There is a follow-up. I think you've partially answered this.
okay.
How are RT losses accounted with meters with grid charging? Are RT losses loaded to the PV or the BESS?
I think RT is round trip. So what I was trying to say is only real, and depends on the methodology that you use. But so in the example of PV producing and BESS charging, you would have two basically different considerations. You have a consideration where the net energy flow is out to the grid. The PV in that case would be the only resource where those losses are attributable to, because it's the only resource sending energy to the grid. If the interconnection's net energy is into the facility, even while the PV is producing, only the battery is pulling energy into the facility. So the losses would only be attributable to the battery. So it's really, and you have to build these kind of logical conditions into a complex metering scheme if you're going to perform it, the smart way or whatever, the good way. Hopefully that hit the question. I think it does. If not,
Yeah.
let's follow it up at the end.
And there is another new question.
Oof.
Do we want to start saving these for the end, or
yeah, let's save them for the end, because I think everyone's
right.
going to want to hear about rig testing, meter certification, and point to point. So
great. So Leo, Jitendra, I'll keep your questions in the queue. If anyone else has questions, go ahead and pop them in the chat. We'll get them at the end. Thanks.
Yep. Sarah, real quick, we're done at noon or 12:15?
12:15 Pacific. So you got about 45-ish minutes.
Lovely. Okay, I thought I was staring at. I thought I had 20 minutes to go. We'll have plenty of time for questions at the end. So rig testing and meter certification requirements and process. CAISO's expectation is that by the time you have your point to point, which is, as Kelsey mentioned, is precious, hard to get, long lead time item, everything should have been pre-tested and the actual test should go smooth. Like this isn't a chance to figure out how it works. This is a chance to show CAISO that everything's already working. Depending on CAISO, they may be lenient and give you some time to fix small issues if you seem adept and those issues seem to just, maybe there's a good reason that you might have missed them. They can even help you troubleshoot, extend appointments, and make sure you get over that point-to-point finish line. Or they can end the appointment immediately once you've got a few issues exposed that they don't think are going to be worked out in a reasonable amount of time, or that you didn't do your diligence ahead of time. So, don't expect kindness, but be grateful when you get it. An important part of the space is just building rapport. Everybody's on limited time, and we're all trying to get the most use of it. Couple considerations per the business practice manuals that CAISO publishes. Your CAISO meter inspector has 5 days to submit site verification documentation after your point-to-point test is completed. Also, all of your devices are going to be locked down, at least your CAISO devices, at the end of the point-to-point. So, your CAISO metering scheme system, whichever it is, and your CAISO rig are essentially should not be changed after the point-to-point. There shouldn't be any erroneous data introduced, but from a metering perspective, those are going to be password locked down. You can't really make a change without coordination. And from a rig perspective, if you start making changes, CAISO is going to know pretty fast. So I've got here, it's the conclusion of your metering, testing, and commissioning activity. Again, CAISO doesn't want bench testing. They want to test the system that's actually going to be operating. They don't want to test your facility as it's going to be operating in their system. All of your inspections and local testing should be complete. And the CAISO actually has a requirement that rig testing should have been complete. What that basically means is that whoever is providing the rig design and programming should have pre-tested all of the individual connections and all of the connections that are behind those connections. So CAISO has terms called originating device, which is any of the devices that you see probably in the bottom right-hand side of this screen. So meters, relays, sometimes power plant controllers, which just aggregate data from different types of devices. The expectation that CAISO has is that the entire data path from the originating device to the rig and subsequently to the point map that CAISO is going to read has been tested. So if a piece of data, like what are your auxiliary megawatts, passes through 5 intermediate gateways or processors or whatever, the testing should be performed from that originating device, the aux meter, all the way up to the rig. So that anywhere that scaling or dead bands or sign conventions, polarity, whatever, could be erroneous, you'll be able to see it between the two devices. I sometimes like to use the example of like driving a car here, right? We have you can see the speedometer and you can push on the pedal, and there's a lot of stuff going on in between that you're not really aware of. And from CAISO's perspective, and a lot of people's perspective, it doesn't really matter. What matters is, that you're pressing on the pedal produces the correct speed according to the correct measurement device, which, side note, is not actually your speedometer, it's the cop's radar, whatever. Details. So anyways, this is a sample comm block diagram, by the way. Kelsey talked about these. This is one of your bucket 1 deliverables. The point of this document is your rig provider should be able to look at your single line and 3-line drawings and CAISO's business practice manual for telemetry. And they should be able to understand exactly what points are required from what devices. And you put them on this sheet. And this sheet that you submit early in your project is going to be the document that CAISO uses to walk through a point-to-point test. So they're going to understand the data path from each originating device up to the rig, and they can ask for all kinds of ad hoc tests to verify data paths, to verify intermediate device configurations aren't misrepresenting data quality, all kinds of stuff. So the accuracy of this document and the updating of this document as you update the design of your project is important. Else, CAISO might just get frustrated that you're trying to test a system that they did not whatsoever approve. Your comm blocks don't have to look like this. I'm kind of an artsy fella, so I like pretty pictures and colors and stuff. But anyways, the data that's represented here needs to be there. So what protocol comes out of each device? Where does it pass through? Each intermediate device, what protocol is that using to talk to a rig? What points originate in the rig? And then, what types of devices are they? At least by, make, model. You don't need to get into too specifics with part numbers and stuff. But for example, I've got up there, the rig has a Yukon point. This is unit connectivity. And that's a logical point generated by the rig that's going to look at things like, well, do you have voltage? Do you have watts? Do you have a breaker position? If you have voltage and an open breaker, those things are like logically do not fit with one another. Your unit connectivity should go false because something doesn't make sense on site. Some piece of data is no good. CAISO should not be letting your site participate in the market and in their system if the data that they're using to serve their full network model is bad. So again, this to bring back an earlier part of the discussion, this is the data that populates the full network model that determines frequency dispatches and voltage. I guess transmission owners do voltage control, but there's an important thing to know that your utility partners will probably also want some of this rig data into their RTU for that voltage control purpose. Anyways, the thing I'm trying to stress is this is the data that populates the full network model, ultimately impacts pricing and operations of the grid. So CAISO is very diligent about testing from a point-to-point testing perspective, which is what I'm supposed to be talking about here. You can expect CAISO to ask you to simulate each of the points listed on this document from the originating device. So and to walk you through what a point-to-point test looks like, usually we start with meters because in addition to being telemetry devices, or in addition to being revenue devices, meters are also telemetry devices. But the revenue component of the test involves loading the meters up with data from a test set. So CAISO can reconcile their revenue billing system with their telemetry system. Basically, the CAISO inspector is going to put a test set on, let's just say, your primary meter, primary and backup meter for the PV, the thing I have grayed out there. They're going to inject, let's just say, 100 megawatts. CAISO will see that 100 megawatts through the rig in real-time telemetry. And then that 100 megawatts needs to also find its way into the revenue registers that will be brought into CAISO's EDAS team through that MV90 system. And that takes time. You know, there's 5-minute intervals. You want a couple of them to make sure that everything is working functionally over time. Energy is a power over time problem. So, you know, you set a telemetry value on a meter, and then you kind of step away from the meter. You leave the test set there and let it populate revenue data for a while, and you're going to move on to another device, and CAISO is going to start calling out devices and data that they want to see from those devices. As Kelsey mentioned, you're going to want somebody from your substation team there on site, or at least remote, but able to access devices locally on site. And devices, I'm talking about those relays and the substation RTAC, anything that's providing that kind of substation data into the rig. And again, CAISO requires that the originating device send the data through intermediate devices, like a substation RTAC, up to the rig. So when we're talking about data that's sourced at a relay, you either need a relay test set to be able to push current and voltage into a relay and produce transformer high side megawatts, transformer high side voltage, gross megavars down at that 351S I have on the screen. You're going to need to either inject voltage and current to produce real measurement output from those devices, or you're going to have to know some fancy tricks about how to simulate from the device through that SEL protocol I have on the screen there, through the intermediate device and up to the rig. I'm mentioning that one specifically because that push is kind of new from CAISO, and it didn't used to be normal to have like substation test equipment as part of a point-to-point test. It can mostly be done through some fancy tricks with forcing data depending on your relay devices, but again, that's all new space. So make sure you either know how to do it or you have your relay test techs on site to be able to perform injections. Depending on the backfeed status of your site, whether or not you're actually connected to the grid by the time you do the point-to-point from a utility perspective, you may or may not operate the breaker points from the relay. What I mean there is CAISO doesn't want you to actually open and close relays, but they want the device that monitors those, doesn't want you to open and close breakers, but they want the device that monitors those breakers to report the data all the way through the system. The other folks that you're going to want to have on hand for your point-to-point test is your power plant controller folks. If you have multiple resources controlled by different folks, depending on which resource is having its point-to-point test, those folks are going to need to be on a call and able to remotely access that power plant controller and simulate values as far back into their system as they can. And again, what you want to prove there is the logic of the power plant controller itself, insofar as it's calculating any of these points, as well as all of the protocol implementations between that device and the rig. As you're moving through, maybe your substation points and your meter hits the time hack where it's time to change directions, try something else, start loading up some different revenue data from a different device. You're going to transition back and forth between set up a revenue meter, take a quick read, let it work for a while you test the next device in the telemetry points list. And then the other thing that I kind of mentioned previously is, you might find a little something, polarities backwards or scaling's off by a factor of 10. If it's small stuff and CAISO's got bandwidth, they might say, hey, all right, so it looks like we have a little problem between that feeder relay and the substation RTAC. Can you guys fix that in the next 10 minutes? Yep. Okay, cool. Let's start looking at the power plant controller while we get that fix in the substation devices. And so CAISO is going to kind of wander around the points list in this document to be able to try to make sure that they get all of the testing done of each individual point within the allotted time. And then since this site is representing batteries and PV, I guess it's an important thing to mark that you may have different point-to-points for different resources because those technologies may come in at different times, like project construction phasing, basically. So you could test your PV if that's ready in February, and then your BESS is going to come online in March. Those would be two different appointments. If the rig in that situation could be shared between those two resources, or you could have two rigs, you'd have two different documents that look just like this for each different resource. That kind of depends on how you're configuring and designing your system. But if it's a shared rig and you've checked half of the points off, you're not going to have to retest them typically. If you've got a new rig and it's sourcing data from all the same places as the other rig, it's a different data path. You're going to have to retest it all over again. So I think that's everything I got about point-to-point testing. That's probably a good spot to stop and look for some questions before we move on to the next one. I only got a few left. Any point-to-point questions specifically, Sarah, sitting in the queue?
Not that I can see in the queue, but if anybody's got any, now's the time to ask.
Cool. This next slide's adjacent, so if they come in, just let me know.
Sure.
After the point-to-point test, and in case the point was missed, point-to-point is supposed to be an end-to-end test of a completed metering and telemetry system. It is not a bench test, and there should not be excessive change after that test. Shouldn't. Small fixes are expected during the sync and test energy project construction phases, especially from the rig as inverters which were simulated come online and such. But at some point before COD, everything should just be up and running and working, because that's how a finished site works. And CAISO is not going to declare an unfinished site as commercially operational. It just doesn't even make sense. So I have in my notes, whatever kind of depraved lunacy is going on to achieve paper milestones to build a project, in terms of CAISO and their 72-hour test, everything needs to actually be built and done. It needs to look like a finished up and running site. And what the 72-hour test is looking at every single device in that telemetry points list having 100% uptime for 3 days straight consecutively. And if you can't achieve that, you're not ready to come into the market. So things that can cause problems there, obviously wireless. If you're using wireless as your communication path, cell phone tower outages and stuff, if it's like a known outage, you might be able to get a pass from CAISO. If you have bad data continuity or just low bandwidth or something that's causing frequent drops in your data, you're not going to get approved to come online with that data path. What CAISO wants to see at the end of a 72-hour test, which comes after your some time after your point-to-point test, not necessarily immediately after, is 72 hours of perfectly good data. Other reasons people can fail this 72-hour test are some protocol misconfigurations. Again, inverter stuff can inverters that weren't part of the point-to-point test coming online and feeding into a power plant controller might not be configured right, and they can cause problems. You can have things like dead banding that just overfill buffers and cause dropouts. Looking at somebody over here in the room. You can have things like backhoe meets fiber line, which is bad, that happens. More commonly, people can be doing local troubleshooting for other systems, like trying to figure out why the PPC isn't talking to a certain part of the array, and they might pull the whole fiber system out to start troubleshooting strands, and you just lost your 72-hour window of perfect comms. So what else do I got in here? Opening breakers to perform electrical connections within the substation. That opening breaker, losing power, can cause devices to drop out, lose communications. The CAISO will see. Likewise, your generator that's on site before you've got backfeed power might just run out of gas, and you're gonna fail your 72-hour test. Or you have the type of people that are like a bull in a china shop. They come into a point-to-point test just thrashing around, making everything work in just enough time to get through the point-to-point test, and then that wasn't actually how you built your site. You got to put everything back the way it belongs, and then things don't work. That's another big reason. That's the rogues and rabble rousers bullet at the bottom. There's lots of reasons you can fail the 72-hour test, but I think the punchline is this is kind of CAISO's proof that you're actually ready to come into the market and or come into the operational system and participate in the market. Everything's up and stable and final. So that's the last real slide I got. Just a quick summary, actual accuracy of measurement, and that comes down to instrument transformer placement, ratio calculation, burden testing, device selection, verification testing. That's the foundation of everything. That meter data is going to flow into a lot of systems. I didn't really hit this very much, unfortunately, in this presentation, but places that data flows is going to be, I mentioned, it's the starting point for your closed loop controls for power plant controls. It can populate your SCADA system or your monitoring platform. It's going to flow into the rig. It's going to flow into your revenue system. You might have shadow settlement, so that data is getting picked up by your scheduling coordinator or some other team that's performing that shadow settlement for you. So meter data is the starting point for a lot of subsequent systems, and the needs of those systems is very important to implement into your design so that the meter and the meter data will integrate appropriately into those systems. There are many stakeholders on these projects, and each stakeholder is going to bring project-specific requirements because all of these projects are unique. And then if I haven't hit on it enough, early design diligence pays back tenfold, at least for me. Early in my career and often in my career, I'm handed design to sort of implement a metering scheme on top of where none of these first three bullets took place. And trying to fit a square peg in a round hole was an unfortunate feature of much of my early metering work. One of my big efforts over the last few years is actually just been to try to work myself earlier into the project design so that I can try to make the cleanest, best metering implementation that's possible. So whether it's me or somebody else, I encourage any of you that are on the project development part of the pipe to take all this stuff into consideration early and design the best project you can. Man, 30 seconds short of perfectly where I wanted to end up on time. I don't know how that happened. But I got time for questions.
All right, great. Well, I'm going to go ahead and unmute everybody or give you the ability to unmute. We had two questions come in throughout the presentation that we didn't answer yet. So Leo, if you're still here, would you like to go ahead and ask your question? And then we'll get to Jitendra after that. And if you would prefer that I ask it, I'm more than happy to.
If Leo's not here, is it a good question?
It's a great question.
Let's just ask it.
All right, I'll go ahead. So why do you need a separate meter on a BES resource for a hybrid application?
I mentioned, I passed over it briefly, but that is typically at the preference of the team that is performing BES controls. There is no CAISO or utility requirement to put a meter there, typically, unless that BES resource is part of a DC coupled co-located application where the BES resource needs to be represented completely independent of the PV. But I can say that every sort of controls architecture that I've seen for a BES specific control scheme prefers the meter there. I don't know what the reasons are, like the specific reasons for why that spot is the ideal spot, but that's just every schematic I've seen puts the meter there. Again, don't know why. I assume it has something to do with, they're really trying to operate the battery, and that's the closest that you can get to sort of the aggregated output of a BES component. By component, I'm not sure exactly what that means, but typically these are like containerized these days. So you might have a 1 MVA BES unit that then ties into that inverter and subsequent or DC-DC converter, and then medium voltage transformer. And the controls vendor is not the manufacturer of that BES unit, that container or whatever. So the best place that they have to interface most closely with that container is at the output of that container, which is going to be on the best side of that DC to DC converter. So yeah, as far as I know, no requirements coming from anywhere. It probably makes the most sense from a design perspective if your purpose is to control the battery itself.
Great, thank you. And Jitendra, I've got your question here still. Would you like to unmute and ask your question?
Yeah, sure. Thank you. Yeah, thank you for this, wonderful presentation, and it's very informative. My question is that, we have a existing power plant, which is a solar plant running from almost last 4 or 5 years. And now CAISO is asking us to add the BESS on this particular plant. However, they want it to be as a co-located. So I was wondering, like, how a co-located plant will work when we have an existing PV plant already running. The reason why I'm asking is because they still say that we can have a co-located with the existing single transformer and the single POI, which is already there for the solar side. So my understanding was like a co-located means, we need to have a separate transformer and the POI for the BESS side, but that's not the case how they look at it.
Yeah, that's a great question, and I'm glad you asked it because that's a common, I don't know about CAISO asking, but the concept of adding BESS to an existing PV facility is a common theme on the grid right now. So great question. Thank you for asking it. The idea of a co-located resource is actually all wrapped up in the idea that the resources share that infrastructure, that interconnection tie line, often the transformer, and then they become distinct somewhere across the medium voltage bus from one another. So if you had 2 separate tie lines, each with its own transformer, then the resources really wouldn't have much to do with each other until they've already entered the bulk electric system, the TO substation or whatever. So really the defining feature of a co-located pair or set of resources is that they do share the interconnection. And so the way that typically when you build a solar facility or built, you would basically size it to fill the available capacity of that interconnection. So 100 megawatt interconnection, 100 megawatt solar facility on the AC side. At the POI, that might be 110, 120 megawatts DC, et cetera, et cetera. And so the idea with co-located, if you're adding additional potential generation output, is CAISO from an operational perspective, they have a thing called an aggregated resource constraint. So it's something that they have in that full network model that will just acknowledge that you have a PV and a BESS sharing these infrastructure and that they cannot be dispatched above the limit of that interconnection. So that helps you prevent against either contractually or operationally exceeding what your interconnection is allowed or able to inject into the system. And then really what you end up doing is you're basically using the available time that the PV is not operating to operate the BESS. So, we have the famous CAISO duck curve where everybody gets off work at the same time that the sun goes down. So the PV comes offline and everybody ramps up their air conditioner and we have this huge surge in demand. And, from a co-located perspective, that just means that while the PV is no longer able to produce that 100 megawatts, the battery can be ramped up to maintain that output. It's going to be a separate resource, so it's going to be a separate dispatch signal to the battery. But again, it'll still be managed behind that aggregated resource constraint. So CAISO is just going to basically keep energy flowing from your interconnection facility, even if it's going to be coming from a different resource. It's not always going to be like a perfect ramp like that. I mean, CAISO could be dispatching your BESS for all kinds of other things, whether it's, late night things or unit outages early in the morning or whatever. I'm not trying to state how these things are operated, but the general theme is that they are flip sides of a coin in terms of time and how they're operated. And then the other thing is, and as I mentioned, the fact that BESS is going to charge while the PV is producing means that there will actually be less electrical losses through the transformer and through the interconnection tie line. So you might end up with a little bit more money in the bank for the PV resources during charging periods. And then it's very seldom that they're really going to be, I guess you can't really discharge them both at the same time. So there's no increased loss impact to that sort of generic facility that I've just imagined here. From a construction implementation perspective, you know, it's going to depend on how you market that BESS, whether you want to just do like a bus extension and put a CT right there on the bus, and you know that CT is going to be able to capture the entire BESS as one sort of metering point, or if you're going to have multiple feeders with meters on them that sort of aggregate up to represent that resource. You know, that's where how you design the bus extension. Again, there are implications from the commercial arrangement that might impact how you might want to design that from an electrical and physical design perspective. So, yeah, I think that's a complete answer, but please feel free to follow up.
Yeah, no, I think thank you that answer. So actually, the best side, the meter can be added because it's a new addition of resource. But for the existing PV, we are like confused whether we need to add the meter at every feeder, because that's like too much metering for a big plant.
Yeah, no, as you started responding again, I actually thought, you know, I didn't talk about the metering impact for the existing resource. So yeah, you probably have, you know, maybe one PPA, one high side meter, and you have a simple metering implementation with your just PV interconnection. And so that resource can be represented at the high voltage. But once you add that BESS facility to the medium voltage bus, you now need to move, or you need to add metering for the PV that will represent that PV resource distinct from the BESS on the medium voltage bus somehow. So I don't know what your bus looks like. You can be one-sided, you could be split, I don't know. But yeah, you could end up with a feeder metering arrangement. You could do, you know, if you're only adding to, let's just say, the north side of the bus, you could put a bus CT on everything that's south of the T point into the transformer, and then you could reduce the metering count that way, have a couple feeder meters to the BESS side of, on the PV feeders on the BESS side of the bus split. But yeah, I'd have to look at your drawing specifically to be able to offer any better recommendations than that. But generally, the goal is always to keep the meter count as low as possible and still be able to capture everything accurately.
Yeah, thank you. That helps.
Yeah, thank you.
Great, thanks, Jitendra. Does anyone else have questions?
Got 5 minutes.
All right, well, if no one else has questions, we'll go ahead and wrap this up. There is another session in about an hour and 15 minutes regarding commissioning in CAISO and more NRI. If you don't have the link to that and you would like that, go ahead and just ping me in the chat and we'll get that over to you. Otherwise, this recording will be available later this week or early next. And appreciate if you can fill out our survey and give us some feedback on how our webinars are going. So thanks again, everybody.
Yeah, and I'll just hang out in case anybody thinks of anything in the next 4 or so minutes. I should have been a responsible adult, thrown my email on this slide so you all could get a hold of me, but if anybody wants to write it down or type it in or however that works, you can find me at P, as in Pat.McCarthy, as in my last name, at artisangrid.com. Artisan Grid is mine and my partner's company, and we partner up well with GridSME. We all love each other around here, and it's a great place to be, and we're happy to help you figure out these kind of problems. That's why we're doing this. So hit me up with any kind of questions that you come up with after the fact, and I'll be happy to address them. Just let me know that it's nothing to do with GridU, and you get a free answer. I do the same thing for my friends that I meet at meter school. You get one free answer out of being a student. So make it a good question. I have a note on here for myself since I still have minutes to talk, but please interrupt. Anything else I find intellectually stimulating. It's not really super metering related, but adjacent. grid codes are rising to meet the problems that have been left on the grid by, I don't know how the nice way to say this is, but basically either it's renewables or the controls of those renewables or whatever, but the long story short is renewable and inverter-based resources are starting to have to do reliability work. The way you do that, if you don't have inertia, is by doing things really fast controls, really fast data capture to understand events that happen and be able to analyze them postscript. So what that ends up being is, from an implementation perspective, is, I implore you all to start thinking about implementing protocol standards and finding the right data protocols to meet these new grid requirements. What that mostly means is, like, get rid of Modbus, please, immediately, and start using, protocols with standards around them. I would asterisk and say DNP, because it's basically an IEC standard. You've got 61850, you've got synchrophasers, you've got, depending on what the purpose, the application of your data need is, there's probably a right protocol for that application. So start thinking about how to standardize and work that into your design documents or whatever. And then the other thing, just from a convenience perspective, when moving documents through, whoever's doing your NRI for you, whether that's GridSME or yourself or somebody else, please flatten your drawings. Nobody needs 300 sheets of one-letter comments. And I can't think of anything else intellectually stimulating right now. Cooperate, be kind to one another.
Probably the most important thing.
Yeah, we're all a bunch of folks working on these big interdisciplinary multi-team projects, and we all want to get them across the finish line. So I try to make it a point to be cool with everybody. Hope you all do the same.